Hey guys, okay. So here in lesson 10, we are going to be switching from writing equations and interpreting things from tables to interpreting, graphs of proportional relationships. So typically if we were in class together, I would go ahead and see what of this sheet you could fill out yourself, but that's just not happening right now. So I'm going to go ahead and walk through this with you guys. So it says here in example 1, Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies. And guys, remember 4 dozen, there's 12 in a dozen, so it would be 4 times 12. Calls for 3 cups of flours. Using this information, complete the chart. So we're going to go ahead and start with making a chart. We're going to have number of cups of flour, and we're going to compare that to number of dozen cookies. I just don't have enough room to write on this on the screen, so that looks really bad, but if you guys were doing this, please take the time to make that look a little prettier. So we know with 3 cups of flour, that makes 4 dozen cookies. So if we were to double that, if we had 6 cups of flour, then we'd have 8 dozen cookies. If we had 12 cups of flour, we'd have, what just happened? I turned off annotating, sorry. We would have 16 cups, or 16 dozen cookies. So then it says, is the number of cookies proportional to the amount of flour used? Explain why or why not. Well, I'm going to go ahead and say yes, but I'll go ahead and show you why. So if we did 4 divided by 3, 1.33333. Okay, what about 8 divided by 6? 3333333. Okay, what about 16 divided by 12? Okay, so they all have the same constant. So I would say yes, because they have a constant of proportionality of 4/3. Then we're going to go on to what is the unit rate of cookies to flour, y/x, and what is the meaning of the context of the problem. So we went ahead and I had 4/3. That is also, I said the constant proportionality there. Well, that's going to be the same as the unit rate, but we'll go ahead and simplify that because it looks like there's a 3 on the denominator and we want a 1 on the denominator. So to do that, I would just write this as a mixed number. So 1 and 1/3. So it's 1 and 1/3 dozen cookies, or 16 cookies for 1 cup of flour. So 1 and 1/3 dozen cookies for every 1 cup of flour. That's what that means. Then we have a graph. So this graph, we have to kind of decide what is the independent variable and what's the dependent variable. So my independent variable here is flour, the cups of flour. That will not change. That is a rate that stays the same. And the number of cookies you can make will vary based on how many cups of flour you use. So we're going to label those sides cups of flour to number of cookies, and we're going to do those in dozens, dozens of cookies. So we're going to go 1 dozen cookies, 2 dozen cookies, 3 dozen cookies, 4 dozen cookies, 5 dozen cookies, just to make it simple. And then we're going to go with we'll go every 3. 1 cup of flour, 1, 2, 3, 2 cups of flour, 1, 2, 3, 3 cups of flour, 1, 2, 3, 4 cups of flour, 1, 2, 3, 5 cups of flour. And so I know that there's 3 cups of flour. That is 4 dozen cookies. And if there's 0 cups of flour, you're going to have 0 dozen cookies. And I'm just going to go ahead and connect that, and that would be our line. I could also do if there were 6 cups of flour, it's just a little outside of here, that you would have 8 dozen cookies, but I just didn't make my graph big enough for that. So keep extending. So does the graph show 2 quantities being proportional to each other? It does, because the points appear on a line, and they go through 0, 0. So then we're going to go ahead and write an equation. So I'm going to go dozen of cookies equals 4 thirds, that constant we decided earlier, and then 4 cups of flour. So D is representing the dozen of cookies, F is for flour, and 4 thirds shows that for every cup of flour, you get 4 thirds of a dozen of cookies. So that is how you would fill that out based on just that simple phrase. And then I will be back to go over example 2 with you.